Hello everyone, welcome to Blender Next. This is my own custom Blender build with completely reworked armature system, specifically designed for game engines. Each bone in Blender Next is presented as one unit vector. It's a joint. Here you have default joint display. You have many joint display models that you can use to tweak your bone axis in edit mode. How this build works? You simply export mannequin this or this one from your engine. For example, I am using Advanced Locomotion System project. You simply import file back, run and play. And nothing else. Only standard functionality. No plugins, no add-ons, no dealing with scaling or animation retargeting. It just works. Also, it works on multiple meshes and multiple skeletons without retargeting. For example, if I select Character Logic Blueprint here and switch Scorpion Rig model to Hutao model from Miku Miku Dance, I download Hutao model and rigged it for Unreal in Blender Next. We switch simple model and we can run and play. Animations will work fine. No animation retargeting, just straightforward, quick and simple workflow. Okay. Let's take a look to skeleton structure in Blender. You select leg bone, here foot right, and add two constraints, inverse kinematics and copy rotation. This green cube is inverse kinematics joint. It should use disabled deform switch. Otherwise, this bone will be skinned when you skin your 3D mesh. If you have some troubles with skinning, you can transfer weights to your character via your proxy mesh. For example, I deformed standard mannequin Animan from Unreal Engine, this mesh, via moving joints and applying armature modifier to mesh. So, how everything is defined here? Only two constraints, inverse kinematics and copy rotation for every chain. For legs, I use copy rotation constraint because I want to keep them in place when I move my character in 3D space. You can extend functionality of your rig as long as you want. For example, here I rigged on standard queen skeleton, queen model. We are replacing custom joints via custom objects is null objects. Red cubes here are inverse kinematics bonus here. They control end of each inverse kinematics chain. See, nothing fancy, pretty simple. And I have simple blue sphere here for spline EK constraint. When you create 3D animation in Blender Next and use spline EK, it can be exported to game engines and other software. For example, Autodesk Maya. So if I select pelvis bone here and add some location, rotation and scale, On frame 16, I will reset my transform to all and add another key. Now we have cyclic animation. Frame, paste to frame 90, copy this frame, paste to last frame. Now we have looped animation. To export animation from Blender Next, you select object, select on the skeleton, file, export FBX, check back animation option, name this somehow V5 spline EK. Now you can import this to Maya. Here, skeleton. Maya loaded hierarchy correctly without problems. You select animation tab. And play your animation. See? It works in ping-pong animation manner. This animation also can be exported to Unreal. So let's close Unreal, load it again. We open games, third-person template, and name this line EK. What we actually can do now? To keep everything simple, I will replace standard eyeball animation with sit-down animation from Blender Next. So I exported this FBX file to V5.4 directory, and I will import V5 spline EK animation. This will be I have running because bonus exists in skeleton but not in animation. I don't care because I am using standard Queen skeleton. See? So bonus with chain tail not loaded here. Animation just works. What I can do now? I can replace skeleton from this mesh. So I open meshes tab and export, this time Queen with skeleton to Unreal. For example, V5 spline EK mesh. I can uncheck bake animation option because I already exported animation. Now when I import animation back, I can clear this space because I will use my own skeleton based on Unreal skeleton. Here we have V5 spline EK mesh skeleton, see, with extra bonus. Now I can import animation here. I will use standard file spline EK, which was as I exported before. For skeleton, I will use UE5 Spline EK Mesh skeleton. This animation sequence will be imported here and can be played in Unreal. Now, when I open my mesh, I can preview animation sequence here on this mesh. What actually I can do now? If I don't want to recreate new animation blueprints, I simply don't know how to do it, I can simply replace skeleton for this animation. I select replace skeleton command and select UE5 Spline EK Mesh skeleton. Skeleton here will be replaced and animation is being edited. See? I got the warning, so I replace this file with UE5 Spline EK animation. Now warning is disappeared. We have animation here. Playing 30 frames per second. Now when I see, here I have this mesh. I load my mesh with Spline EK. It will be played with animation blueprint. I can save, run and play, and we have object working with my custom animation for idle pose for this character. What actually I can do now? I can attach a sphere to this bone, for example, this one. So it will be moved together with character after export. So I create a sphere, move the sphere in place to Spline EK. I apply transform to object because it should be locked to center of the world. Because every bone in Blender Next use world space transform coordinates. I select sphere, select this one, Ctrl P, and I select this soft weights command. This hard weights command is still in development. Sphere will be attached to mesh. Now I select mesh, select sphere, select skeleton. File, export, FBX, and select UE5 Spline EK Mesh. Re-input with file and select UE5 Spline Mesh. Character imported with a ball on a tail. When we play, ball will be played too. See? And even ground position will be saved, because skeleton Unreal already have chain for tail. That's how it works. Easy enough, I think. If 3D animation has been correctly recorded on latest Unreal Engine 5 skeleton, you can import and link animation from engine to this animation and make combined animation. How it works? Select Animation Screen tab. Select MF, run FAD file and Asset Actions Export. And choose UE5 mannequin folder. Now we will use MF run FAD file. Save and check all checkboxes, I don't usually use them. File, import f by x, mf, run f for the animation, import this one. This animation will be imported. Here it's located, see? So we limit scene range to frames of animation. I'm using plugin XPoolKit for just for one button, match scene range with current action range. Now I select skeleton, select animation from Unreal, control link transfer data, link animation data. Now this animation has been linked, but by some strange reason, character have moving hands. Why is this happening? Because in my Blender build, EK root motion is not supported. So every time when you import and edit animations, you should create them and load them without moving root. So you open this tab, let's Ctrl Z, back to before linking. Select root 001 here, joint, and remove all frames except first frame. Otherwise Unreal will throw a warning that some tracks are missing. So animation now is playing on place, see? Now we select skeleton, select animation, link, animation data. Now we have linked combined animation with moving tail, with dynamics and everything. What now we can do? We can simply export this animation to Unreal. We spline EK and run LBX file with bake animation option checked. Now we open Unreal, run F4D, use spline EK run file. This will throw a warning because some bonus are missing, not a problem. We will replace skeleton to main and re-import this new file to main file, spline EK run. We have running animation playing with spline EK with 30 frames per second frame rate. Now, if we run, our tail will be floating and moving, which we made in Blender before. So, your animation possibilities with linking, retargeting, combining are now limitless. You can do whatever you want. How to start working with my build? First, you import your RBX file. I will use Animen from Advanced Locomotion System because it have much more less bonus and much more complex animations. I select pelvis bone here and use extrude joints command to create new joints from selected. Extruded joint will have same axis and bone roll. To define rotation, I mean main axis for this joint, you should switch to joints rotation mode and click on joint. This will change joints rotation. When you click in joints rotation mode, you select bone tail, so you can tweak bone position or axis. When you use rectangular selection, you will tweak position of bone in 3D space. This is how it works. Click and rectangular selection. Select rectangular, use extrude joints command. You created extra joints from single one here. To create symmetrical joints, you should change names first. First, I will move joints to right, select those joints, and use names, auto-name left, right, to add underscore right suffix to selected bonus. Now I will use command symmetrize. If an armature name exists, I mean suffix for symmetry, symmetrical joints will be created. Now you can enable symmetry and start tweaking your joints symmetrically in whatever position you want. Everything depends what type of 3D animation you use. To create controllers for your skeleton, you can simply duplicate existing EK joints. Here, for example, those ones. Via duplicate command in joints mode. Duplicate function here. Each joint, when you duplicated it, according to Unreal Engine inverse kinematic structure, should be placed in the end of your joint chain. I will use names, alt-name left, right, and use symmetrize command. Now you can select joint, which we just created, go to pose mode, right button constraint, inverse kinematics, EK, target them. We will use root and bone, EK joint, which we just duplicated here. I will use rotation and range 3. See, we have inverse kinematics. Same for symmetrical mesh part. Also, guys, I would like to say a few words about availability of this build. This build will be available on my ArtStation Marketplace and on my Boosty pages. I'm selling my tools on both platforms because I believe that everyone, regardless of what country they live in, should have access to my tools and free updates for them. On Boosty you will get 50% discount for Blender with source code. Also, I'm selling Blender since it's a free program. I spent almost 2 years on development while figuring things out. Also, I can sell my own versions of Blender if I provide source code, according to developers FAQ from website. Also, Blender Next is available under the same GNU GPL public license on both websites. Feel free to do whatever you want with this build, extend functionality, and do whatever you want. Now Blender Next is yours forever. Actually, I started development of this build because I believe that tools should improve and indie game dev should not pay a lot of money to create nice and cool content. We should simplify 3D artist workflow if we can. Thank you very much, guys, for watching this video. See you in the next tutorials on the video channel.